say that with hesitation because it's been a busy couple days. So what do you got going tonight?
Some quadratic problems.
Okay.
So a parabola has a vertex at 5, 7 and goes to the point 7, 2. What other point must be on the parabola? Why?
Alright, we'll go to 5, 7. That's its vertex. And they're saying that 7, 2 has to be on the thing. So if I go out to 7 and go up to about there, 7, 2, well, what do we know about the vertex? It's in the line of symmetry.
Yeah.
So what other point needs to be on there?
3, 2?
Yeah. So the parabola goes like this. Okay. What else?
A parabola goes to points 3, 7 and -5, 7. What is the axis of symmetry?
So this parabola is either going to be like this or maybe like that. In either case, the axis of symmetry is the same. Where is it? In other words, the vertex is halfway in between those 2 points.
-1.
That's it. In other words, the axis of symmetry is a line. That's all they asked, right? What was the axis of symmetry?
Yeah.
Okay. Yeah, because we can't really tell where the vertex is. It could be a number of places, because we could be dealing with a parabola that looks like this, or we could be dealing with a parabola that looks like this. So we don't know where the vertex is, but we do know the axis of symmetry is between these 2 points, because the parabola is symmetrical about those 2 points, or about that axis of symmetry. I'm sorry, what?
How would you find the vertex from that?
You can't from that information. Like I said, I can draw 2 different parabolas there that have 2 different vertexes that both go through that axis of symmetry. I didn't draw this very good to scale. Let me move this over to where that axis of symmetry splits it. And now, here's one parabola. Goes through those 2 points, symmetrical about that axis of symmetry. Well, here's another parabola. Goes through those 2 points, is symmetrical about that axis of symmetry. Both of them have different vertexes, at least different y-coordinates of the vertex. They have the same x-coordinate. And the x-coordinate of the vertex is always the same as the line of symmetry. X equal that line. In other words, x equals -1 is the axis of symmetry. What else?
Convert the quadratic f of x equals x squared plus 10x plus 22 to vertex form.
Okay. Tell me what vertex form is.
Y equals a parentheses x minus h squared plus k.
So we have to make this quadratic look like that. Well, you do it by completing the square. And basically, let me add the y. Here's how you complete the square. You isolate the terms that have an x in them. You set the constant over here to the side. So at this point I haven't done anything, right? Now put parentheses around that and complete the square inside the parentheses. How do you complete the square?
Divide 10x by 2 and then square.
Just 10, not 10x. Just the coefficient, 10. So what do you get?
25.
Okay. Now, me writing in 25 like that, I just changed the whole value of that equation. So what do I need to do to the same side to counterbalance that 25?
Add 25 to 22.
Subtract 25.
Subtract.
Yeah. Notice that now the entire right side of the equation equals what I started with. The 25s would cancel, and you'd be left with just the 22. Okay, you with me?
Yeah.
Okay. Now, the whole reason we did that is so that we can write this quadratic as a perfect square. Now, I add those two numbers together, and I get -3. And presto, I have it in vertex format. A is 1. H is -5. Let's list it. A is equal to 1. It's implied, but it's not written, but it's still 1. H must be -5 because I'm looking at an x plus 5. It's supposed to be x minus h is the general. H has to be -5. And k is -3. Not that we have to list that, but once you get it into vertex format, like we just did, now it becomes much easier to graph. If I want to graph that, I know exactly where to start at the vertex, -5, -3. I know it opens up because it's got a positive coefficient, so it looks something like that, which is pretty good. I mean, I didn't draw 3 points of the parabola, but I know where the vertex is. That's the most important point. I could easily figure out 3 points, but as all they said is get it into vertex format, and we did. In fact, I didn't really need to do that part right there. Once I got it to there, I'm in vertex format. Okay.
So what's the domain of it?
Okay. What is the domain of it? Let me redraw it.
Negative.
Let me redraw a rough estimate of it, but enough of an estimate that we can figure out domain and range.
Would it be...
Read the domain from my graph.
negative infinity, infinity?
I'm sorry. Yes. Negative infinity to infinity. What's the range?
Bracket negative 3 infinity?
Good. Okay.
Is the minimum negative 3?
Yes, it is. In other words, when they ask about minimum or maximum, they're asking about the y coordinate of the vertex. It occurs when x is equal to -5, but the minimum is -3.
On what interval is f increasing?
Okay? Increasing means going from down to up. So where on this thing does it go from down to up? Oh, I should have said from low to high.
Negative 5 to infinity?
Yes. With a parentheses around both.
Why parentheses?
Because at -5, it's perfectly flat. Where is it decreasing? Let's talk about that first, and then we'll talk about what's going on exactly at -5. That's where it's increasing. The next part of that question is, where is it decreasing?
Negative infinity, negative 5?
Now, I can't use brackets on both, right? I can't use a bracket here and here, because then I would be saying that at 5 it is both decreasing and increasing, which wouldn't make sense, or at -5, excuse me. So this thing is always decreasing up to -5. At -5 it's neither increasing nor decreasing, and then from -5 to infinity it's always increasing. Anything else about that particular function?
No.
Okay. Do we have another one of those to do? Should I leave this general format up?
No.
All right.
Use the discriminant for the following. Are the roots of y equals 2x squared minus 7x plus 6 real or imaginary?
What was the constant? I didn't quite catch it.
Plus 6.
Okay. What's the discriminant equal to? I mean, with letters. It starts out b squared. What's the rest of it?
Minus 4ac.
Yeah, that is the discriminant. Not this, but the part that's under the radical. That's called the discriminant. So what is it for this equation?
negative 7 squared
It's 49.
minus 4 times 2 times 6.
49 minus 48. The discriminant is 1. So, what does that say about our solutions to the quadratic formula that has that inside of a radical sign?
There's 2 real roots?
Yes. If it was negative, what would it mean?
Imaginary?
How many?
Or no real roots?
2 imaginary roots. If it's equal exactly to 0, what would it mean?
1 real root?
Uh-huh. Because if it's equal to 0, that completely goes away. You lose your plus or minus, and the only answer is minus b over 2a. So that's why the discriminant has its own name, is because frequently when you're trying to solve a quadratic, you'd like to know whether you have real roots or imaginary roots. So the quickest way to determine it is to figure out what b squared minus 4ac is, whether it's positive or negative. You know, maybe it's a real-life problem and you go and you look at the discriminant and you get an imaginary answer. You're not interested in the imaginary answer. You stop. But if you get a real answer, maybe you are interested. So they give it its own name.
These are a little different,
Okay.
but they're nonlinear problems.
Okay.
A rectangle has an area of x squared plus 18x minus 4 and a width of x plus 20. What is its length?
What's the formula for area?
Base times height.
Well, it's width times length, since that's the terminology they're using in this problem. So, in other words, the area is this quadratic, and the width is x plus 20, and they want to solve for L. So I need to divide this by x plus 20. Do you know how to do long division with polynomials?
No.
Okay, let's go through the long division. Did I get my terms right here? The area is x squared plus 18x minus 4?
E.
40. Ah, okay. Instead of making this a division problem, let's make it a factoring problem. It'll be a lot easier than teaching you long division, although perhaps you need to know that. I don't know. You tell me. We can factor this. This is just a factoring problem. How do I factor this?
X plus 20, x minus 2.
So now, what is the length equal to?
X minus 2.
Uh-huh. Now, when I ask you if you knew how to do long division, here's what I meant. You tell me if you've had to do this. Now would be as good a place as any to cover it if you need to do it for this test. In other words, if you decide not to make it a factoring problem, but make it a long division problem, this is the way I would do it. You ever had to do anything like this?
No.
All right, well, let's not spend time doing it.
A circle is centered at the origin if one endpoint of a diameter is at negative radical 5 and radical 5, what is the other endpoint?
All of a sudden I cannot understand anything you're saying. I got the circle is centered at the origin. What else?
If one endpoint of a diameter is at negative root 5 and root 5, what is the other endpoint of the diameter?
Okay. So let's find that point on our xy coordinate. Well, that's this way, that amount, and up that amount. So we'll call that root 5, negative root 5. And we'll call that root 5. So that coordinate is right there. And that is one endpoint of the diameter. So where would I find my other endpoint? Which quadrant?
The first.
Now, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant.
The third.
Remember, the diameter has to go through the center of the circle.
So the fourth.
Yeah. The other endpoint has to be about there. That's the diameter, and the circle is like that. And that's the only spot where it could possibly be. And that has to be plus square root of 5 minus square root of 5. The opposite, so to speak, coordinates of this one, which was minus square root of 5 plus square root of 5. Okay, let's lose that so it's not so confusing. Just remember, your diameters always go through the center of the circle. Now, did you say you're not preparing for a final, or you are?
I'm not.
You're not. You're one of my few students that is not preparing for a final. So does that mean we're going to have a session Thursday night at 6:30?
Yeah.
Okay, good. Because with everybody else, it's like 7 sessions a day and then nothing. It'll be nothing for 3 weeks. So I'm looking forward to the vacation, but I actually prefer to work. So what else you got? We got about 5 minutes.
The diameter has the endpoints -4, negative radical, comma, radical 7. Wait, sorry. -4, comma, negative radical 3, comma, radical 7.
Hold it. Negative radical 3? Or, no, you said -3 minus radical 7. Like that?
No, you had it right before.
Really? Like
Yeah.
that? Okay.
And then comma, radical 7.
Where's the comma go? I've got it between the -4. Ah, the comma goes here. Right?
There's a positive radical 7.
There's no negative sign there?
No.
So is that?
There you go.
There we go. We got it right?
Yeah.
Okay.
Yeah.
That's a correct, believe it or not, that is the correct way of expressing that number. It's the only correct way. if I were to look up in a calculator what this is and then combine it with that, I would have to round it off. I would get something on the order of minus 5.7 dot dot dot, and then I would have to round it off. So if I want to be 100% precise, this is the way, the terminology I use, is I treat the irrational number as being added or subtracted to the rational number. Okay, so that's one endpoint. Right?
Yeah. And then the other one, the opposite.
They want us to come up with the other one?
No, they have and parentheses -4 plus radical 3, comma, negative radical 7.
Okay. I get that right?
Yeah.
Okay, so those are the two endpoints of a diameter of a circle?
Mm-hmm.
And what do they want?
And the equation?
Of the circle?
Yeah.
Okay. What's the general equation of a circle? Does this say where the center is, by the way? Is the center at the origin?
It doesn't say anything.
Let's see, the other problem went from, let's see, one solution was that, and the other endpoint was the reverse. It was that and that. So can we tell if we're at the, and that was at the origin. This looks like it might do the same thing. No, this is not the negative of that. Is there a -4 or is that +4?
That is negative.
So this is the conjugate of this?
Mm-hmm.
Which would indicate to me that the origin is not the center of this circle. Well, hold on. Here's the equation of a circle at the origin. Well, we certainly know what the radius is. What's the radius? Or do we? Let's see. If I try to figure out approximately where this is, it's, I said minus 5.7, so we'll put minus 5 there. Square root of 7 is, say, 2.5. So there's one endpoint. The other endpoint is at an x value of -2.3 and a y value down here at negative, right there. So if those are the two endpoints of a diameter, there's only one circle that can come from that, and that's this one, which means the equation of the circle, we have to go to the general equation of a circle, which is the following: x minus h squared plus y minus k squared equals the radius squared. Well, thinking for a moment. The midpoint between these two endpoints is the center of our circle. right? In other words, if I gave you an x 2 points in the xy plane and I said find the midpoint, you'd be able to do that. And it's the halfway point between that, and you'll notice that that halfway point is minus 4, and 0. In other words, the center of our circle is at minus 4, 0. Now, I got that by finding the midway point between the x coordinates, which is minus 4, 0, and the midway point between the y coordinates, which is 0. Excuse me, the midway point between the x coordinates is minus 4. The midway point between the y coordinates is 0. That's how I got the center of the circle. So now I know my equation. It's x minus the x coordinate, or x plus 4 squared, plus y minus the y coordinate, 0, squared, equals the radius, which has to be minus 4 squared, or rather 4. So there's the equation of the circle. That's a toughie. That is a tough one to end my week on. Well, I guess I'm not ending my week because I'm going to see you Thursday night, but I'm ending my maddening 2 days. You good to go, Mina?
Yeah.
Okay, I'll talk to you on Thursday.
All right.
All right. Bye-bye.